Hello guys, in this video I would like to talk about supply registers and take a look at how to properly specify supply registers for a design airflow. Supply registers, which are equipped with dampers, used to deliver warm and cool conditioned air from a heating or cooling system into a living space. There are multiple types of supply registers, such as flow register, one-way ceiling register, and three-way and four-way ceiling registers. So when we try to specify supply registers, we need to first consider some important factors which play a very important role in the overall performance of supply registers. The first one is phase velocity. When selection of the phase velocity, we must consider the associated pressure loss that deals with each relative model. If you look at this engineering data, the recommended phase velocities for residential areas are in the range of 500 FEM to 750 FEM. The second one is the pressure drop, which is measured in inch of water column, so we should not select pressure drop higher than 0.03 inch of water column for residential areas. So if we have a longer distance or taller ceiling, in this case we'll need a higher pressure drop. The third one is air volume. So when selecting registers, we have to select the air volume which they are rated for. The fourth one is throw and spread. Throw is how far and how many feet the air throws from the register, and the spread is how wide the air is spread from the register into living space. The fifth one is effective area or correction factor, which is also known as ACA, is a laboratory calculation area and square feet of an outlet based on average measured velocity between vents. The sixth one is the terminal velocity, which is the velocity of supply air from registers drops between 75 FEM and 50 FEM. The seventh one is the free area total of spaces, which are measured in square inches between vents, so we don't be confused. This is different with effective area or correction factor, which is determined in laboratory through airflow measurement and actual opening between vents. The eighth one is noise criteria or NC level. So designers should always take into account acoustical performance when selecting grills, registers, and diffusers. And here noise has to be controlled and rated correctly when it comes out of registers. So it is very important to understand how many factors noise criteria readings are determined, what they mean, and how they should be applied. If you take a look at this engineering data, the recommended NC level for residential area is 30 to 35, and it should not exceed 35. So if you are trying to keep the room quieter, we should select the lowest noise criteria, 15 or 20. And last one, another factor which can cause the NC level goes up is an increase in phase velocity, and it can also create more pressure resistance against the blower's delivery of air volume and increases the noise. For example, if the phase velocity of 250 FVM exceeds to 300 FVM, the answer level will go up from 15 to 20. And if the phase velocity of 425 exceeds to 500 FVM, the answer level will also increase from 30 to 35. And if the phase velocity of 500 FVM exceeds to 575 FVM, the noise criteria will also go up from 35 to 40. Let's say we have a living space. Our design flow for the living space is 121 CFM with a phase velocity of 500 FVM. At the answer level of 30, we want to know what the required size we need and what the pressure drop over the resistor is, and the effective area or acre of the resistor, the expected throw from the resistor, and the expected spread from the resistor. If you use this engineering data by selecting the phase velocity of 500 FVM, that's gonna give us a pressure drop of 0.016 inch of water column with an expected throw of 5 feet from the resistor, an expected spread of 8.5 feet from the resistor, and an area of 5 by 14 square inches. For the design airflow of 21 CFM with a phase velocity of 500 FVM at answer level of 30. And here, as you can see, for a flow rate of 21 CFM, the approximate pressure drop over the resistor is 0.016. The effective area or acre is 0.243. The expected spread from the resistor is 8.5 feet, and the expected throw from the resistor is 5 feet. And that's it for this video. I appreciate you for watching this video.